Hi guys, today we're talking about physics of the atom. Subatomic particles. Atoms are the smallest part of an element that still retain the element's chemical properties. However, they are made of subatomic particles called protons, neutrons and electrons. Now, protons, they've got a relative charge of +1, they're positively charged. Neutrons are neutral, they've got no charge. And electrons have got a negative charge of -1. Now both the proton and the neutron have got the same relative mass of 1, whereas it would take 1,840 electrons to equal the mass of a proton or a neutron. The representation of nuclides. The nucleon number, also called the atomic mass number, is equal to the sum of the number of protons and the number of neutrons. The proton number, also called the atomic number, is equal to the number of protons, and in a neutral atom is also equal to the number of electrons. So here we've got X, which is the element symbol, Z, the proton number, which is equal to the number of protons, which is equal to the number of electrons in a neutral atom, and A at the top there, well, that's the nucleon number, which is equal to the number of protons and the number of neutrons combined. So let's have a look at an example. Well, here we've got lithium, Li, and it's 7 and 3. So lithium has 3 protons. Lithium also has 7 nucleons in this example. So 7 minus 3 is 4. So therefore we know lithium has 4 neutrons. So there are Li, lithium. The proton, it's got 3 protons and also 3 electrons. It's a neutral atom as far as we know. And it's got 7 nucleons, and we know 3 of those nucleons are protons, so the rest, which is 4, must be neutrons. And here we've got a basic model where we've got the nucleus in the center, which is containing neutrons and protons. We've got electrons that orbit around in shells, and it's important to note that the atom is roughly about 10 to the minus 10 meters in diameter, whereas the nucleus is about 1,000 times smaller, which is 10 to the minus 14 meters in diameter. Isotopic forms. An element can exist in various isotopic forms. Isotopes have the same number of protons but a different number of neutrons. So here we've got carbon 12, carbon 13 and carbon 14. Now they've all got 6 protons and 6 electrons. So let's have a look at the number of neutrons. Well, firstly, if we do 12 minus 6, we get 6 neutrons for carbon 12. And 13 minus 6, we get 7 neutrons for carbon 13. And carbon 14, well, 14 minus 6, we get 8 neutrons. Nuclear processes. Nucleon number, proton number, and mass energy are all conserved in nuclear processes. So here we've got a nitrogen nucleus and a helium nucleus that are fusing, and they become oxygen and hydrogen. So if we look at the nucleon number, well, we've got 14 plus 4, and that equals 18, and that should be the same on the other side. So we've got 17 plus 1, and that makes 18. If we look at the proton number, well, on the left-hand side we've got 7 plus 2, which is 9, and on the right-hand side we've got 8 plus 1, which is also 9. Radioactive decay. Radioactive decay is the random and spontaneous breakdown of an atomic nucleus resulting in the release of energy and matter from the nucleus. So that word random, well, it means you cannot predict when an individual nucleus will decay. And the word spontaneous, well, it means external factors such as temperature and pressure will not affect the rate of decay. Let's have a look at a graph here where we've got the count rate and time of a radioactive substance, and the activity decreases as the radioactive substance decays, but you can see the count rate fluctuates as the process is random. Okay guys, hope that's been useful. Don't forget to comment, like and subscribe if you don't mind. Okay, adios amigos, ciao for now.